Okay, we were discussing about the random variables, and before we start with the random process, which is extension of the random variables, we would like to discuss the concept of correlation among random variables. So, suppose we have two random variables, x and y, and these may be the outcomes of two random experiments. Okay, so you perform one experiment, and the outcome of that experiment is mapped to real numbers, which we call as random variable x, and we have the second experiment. The outcome of that experiment is mapped again to the real axis, and that we call as a random variable y. Okay, so we will see a statistical parameter that is basically used to define the correlation between these two variables. Okay, that defines the nature of dependence between x and y. Okay, that how x is related to y. Okay, and that is called basically covariance. Okay, so covariance of two random variables x and y is defined as sigma xy, which is expected value of x minus x bar into y minus y bar. Okay, or I can write it as x minus x bar y minus y bar mean. Yes, मेरी क्लास अभी थोड़ी देर बाद आना, ठीक है. Okay, so if you look to this equation, we call it as the covariance between x and y. Okay, and definitely it is a natural extension of the variance. If you take x and y both times, you get sigma x square, which will be equal to x minus x bar into x minus x bar, expected value of this, and that is nothing but x minus x bar square, the average value of this. This is what we already know, it is called as the variance of the random variable x. Okay, and this is what we define as the covariance. Okay, now you see that how this covariance parameter, it establishes the correlation between the two random variable x and y. Okay, so suppose you perform the random experiment and you have the two variables x and y that may be dependent upon each other, or that they may not be correlated with each other. Okay, so you have random variable x here and random variable y. So these are the values which the random variable x can take. In fact, they should be small x, and these are the values which the random variable y will take. Okay, and if you plot these x and y values on the same graph corresponding to a value of x, what you get a value of y. So you may have a plot like this. Maybe suppose this is what we call as a scatter plot. Okay, So the scatter plot will show that if the random variable x takes this value, maybe x1, then at that time the random variable y will take this value of y1, and so on. So if your random variable x takes this value, then the random variable y will take this value, okay, and so on. Like suppose it may be that x represents the temperature of a city, okay, and y represents the volume of the cold drinks, okay, the sale of the cold drinks on that day, okay. So we perform this measurement over several days. So on one day you see what is the average temperature of the city, that is x, and what is the volume of cold drinks sales on that day, so you have corresponding y. Then you repeat this experiment a number of times, so you have a plot between x and y. So on this axis, this x, it represents the temperature, average temperature of a day for different days, and correspondingly y represents the volume of the drinks that is sold on that particular day, okay. And it is more likely to see that as the temperature will increase, there will be increase in the volume of sales, okay. But so it means if I suppose take x here, then y will increase. If x is high, y is likely to be high, but it is not always true, okay. It means even for a low temperature, the volume of the soft drinks can be higher. That may be on special occasions, like there is a cricket match, okay. So even if the temperature is low, you can expect a high volume of this cold drink sales, right? So this is what is a scatter plot, okay. This is x, this is y. So x are the values which the random variable x can take, and this y represents the values which the random variable y can take. And this x and y, these two random variables, they are basically outcome of two different random experiments, okay. So we are trying to see whether y is correlated with x or not, okay. So that we have defined with sigma xy, which is x minus x prime into y minus y prime bar. Now if you look to this parameter, which I have called as covariance, so if you plot, if you find x minus x bar, now x bar is the mean value of this random variable x, and y bar is the mean value of the random variable y. So when you subtract the mean from the random variable x, of course you will have a zero mean random variable, and similarly when you subtract the mean of the random variable y from the values of the random variable y, you will get a zero mean random variable, okay. So that can be seen as, suppose this is the mean of x bar, and this is the mean y bar, the random variable y. So x minus x bar and y minus y bar simply means that you are basically shifting the origin of this plot to this point, okay. So I simply shifted this, so it becomes like this. You have x, you have y. Now the center or the origin of this scatter plot will be shifted to this, because the mean will be now around when you subtract this from this and this mean from this, you basically have the zero mean in both cases. So x minus x bar, and if I plot here y minus y bar, that is same as this plot, but the origin will be shifted to 0 0, okay. So I have to plot the same data. The data is same, The data is same. I have simply shifted this point to this point, so it will become basically like this. Okay, this is what I have written here: x minus x bar and y minus y bar. So initially we have plotted it x versus y. Now we are plotting it x minus x bar versus y minus y bar. Okay, where the origin of the scatter plot will be moved to their mean values. Okay, now you will see that in this plot, since now you are multiplying them, you are multiplying this with this, and then you are finding the average value or the mean value. Okay, and if these two variables x and y, they are correlated, and if they have a positive correlation, that means if x increases, your y is going to increase, and if x decreases, the y is going to decrease. Definitely in this case, when your x increases or x minus x bar increases, your y minus y bar will also increase. When your x minus x prime decreases or it is negative, your y minus y prime will also be negative. It may not be always negative, but it is more likely to be negative. Okay, there may be some cases when your x minus x prime or x bar is negative, but you get y minus y bar as positive. That is for some cases, but in general, if you have a positive correlation, then if one variable increases, the another variable it also increases. Okay, and if the another decreases, the second one also decrease. And if you find this product, so if it is positive, this is positive. If this is negative, this is negative. It means in both the cases we are going that this product is going to be a positive quantity. Okay, and if you find its average value, it is going to be a positive value. Okay, so it means if I say that if the covariance of the two random variables is a positive large value, in that case you can say that these two random variables, they will be correlated. Okay, or they have a positive correlation. Positive correlation means, so the random variable y will be in harmony with random variable x. That means if x increases, y increases, and if x decreases, y decreases in most of the cases. Okay, and the second situation can be like this. This is x minus x bar, and this is y minus y bar. So if you have a negative correlation, it means that if x is tends to increase, then y tends to decrease. So you can have a scatter plot like this. Okay, something like this, with some exceptions, of course. So in this case, if x increases and y decreases, or if x decreases and y increases. Okay, so in that case, when x minus x bar will be positive, then y minus y bar is likely to be negative. Okay, so for positive values of x minus x bar, y minus y bar will have negative values, and when x minus x bar takes negative values, your y minus y bar will take positive values. Okay, so if you find the product, in any case, it is going to be the negative. Okay, because if this is positive, then this is negative, and if this is negative, then this is positive. So the product is going to be a negative number, and if you find the average value or the mean value of this expected value, that is going to be a negative number. Okay, so it means when you have a negative correlation between the two random variables x, your covariance is supposed to be a negative value. Okay, and if you take the last case in which x and y, they are uncorrelated, it means the outcome of y is basically not dependent on the outcome of x. So x minus x bar and y minus y bar. So you can have a random scatter plot like this. So in this case, if x increases, then y can equally increase or decrease, and if x decreases, y can increase or decrease. Okay. So this product x minus x bar, for some values x minus x bar will be positive, and at the same time y minus y bar can be negative. Okay. And for some other values, if x minus x bar is negative, then y minus y bar will be positive. So in the product, definitely you can get both positive and the negative numbers, and if you find the average value, it will tend to be 0. Okay. So if the covariance of the two random variables sigma xy, which is x minus x hat into y minus y bar, the average value of this, if it is 0, we say that x and y are uncorrelated. Okay. So if the covariance of the two random variables is 0, we say they are uncorrelated. Okay. And you can expand this. See, you can expand it like this. Maybe if I expand it, it is x into y bar minus x bar y whole bar, x bar into y, then whole bar, and minus into minus equals plus x bar y bar whole bar, and then minus x bar y, sorry, x y bar, x y bar whole bar. Okay. And it can be written as x y bar minus, see, this x bar is basically mean value of random variable x, so it is a constant. Okay. So you can take this outside this expected value. What you get here is y bar minus, you can write it as x bar y bar, and minus, sorry, this is plus x bar y bar, and again minus x bar y bar, because here y bar is a constant, it will come outside the expectation, you will get x bar. Okay. So one of these two terms will cancel each other, you will get x y bar minus x bar y bar. This is the covariance of x and y. Okay. So this is basically, this term is generally called as the correlation of random variable x and y, which is defined as expected value of xy or xy bar. Okay. So the covariance of the two random variables x and y will be equal to their correlation minus the product of their expected values or the means. Okay. And we have said that the two random variables are said to be uncorrelated if their covariance is 0. It means your xy bar should be equal to x bar y bar if the two random variables are uncorrelated. Okay. So this can be another statement. So two random variables x and y are said to be uncorrelated if their correlation is equal to the product of their mean values. Okay. So generally we defined a correlation coefficient, okay, which we call as rho of xy, which is sigma xy divided by sigma x into sigma y. We normalize it, okay, so that this goes between the range of this goes between -1 to 1. Because when you say, suppose when you find the correlation here, you get some value, okay, and you have another two random variables, maybe x1 and x2, they also have some correlation which is a positive value. So how you say that what is the correlation, degree of correlation between the two random variables? Okay, here you get some positive value, and for two another random value you also have a positive value, but these positive values they are different. Okay, so we cannot measure exactly that how much these two random variables are correlated, so that is why they are normalized with their standard deviations, and this will give you a correlation between -1 and 1. So when it is 1, the two random variables x and y, they are highly correlated, or they have a positive correlation, and when it is -1, they have a strong negative correlation, and if this correlation coefficient is 0, definitely then there is no correlation between the two random variables. Okay, so for the uncorrelated random variables, you can also say that if suppose x and y, if x and y are uncorrelated, and you define a random variable z which is x plus y, then you can simply find the variance of this will be equal to sigma x square plus sigma y square. Okay, and this you can directly prove. So if I find sigma z square, which is z minus z bar square mean value, this is the variance of z, and z is x plus y minus x bar plus y bar whole square, which I can take as expected value of x minus x bar plus y minus y bar whole square. Okay, and you can use here a plus b square, it will become x minus x bar square mean value plus y minus y bar square mean value plus twice of expected value of x minus x bar into y minus y bar. So this becomes simply sigma x square, this becomes sigma y square plus 2 times this is covariance. Okay, and if I say that the random variable x and y they are uncorrelated, then this part is 0. So accordingly you will get sigma z square as sigma x square plus sigma y square. Okay, and we have also seen that the variance sigma x square is basically e of x square minus e square x. That is the variance of the random variable x is the mean square value minus square of the mean. And if you take two random variables x and y with 0 mean value, then their variance and mean square value is same. Okay, then I can expand this relation like this, that x plus y, the mean square value of z, which is x plus y, will be equal to the mean square value of x plus the mean square value of y. Okay, in the next we will discuss now the random process.